Thanks all of you for joining to this webinar for custom bridge modeling using functional component. This webinar is the third section for parametric modeling. I believe you had understand how to create the variable and assign the constraint to 2D profile. Please take a look at previous session if you will not attend to my presentation. In this chapter, I'm going to explain how to create custom pier using functional component. This model consists of copying 1 and 2, column cap, grooved column, putting in pile. Before create this model, we need a naming plan, which direction is going to be width or length for each 3D component. I will consider the putting eccentric length to both bridge axis and thickness or height has to move over from the base point. So this point will restrict the using 3D text. Also, each 3D component will not be able to connect it completely. So I will connecting it using 3D dimensions. I'm going to explain how to create the custom pier in MicroStation. Create a new label for guideline. And place the lines for the working point. And connect each line using coincident and restrict line and node using the pix. Place a rectangular for copying. Assign equal distance to generate equal width and length. Add a variable for copying width and length. Assign it to copying profile. Add variables for copying and hunch height. Already I told you, this modeling has 2 copying dimensions. Create a solid for copying 1 using extrude. And extract a surface to generate a copying 2. As you know, I'm already select associated with extraction, but you need another rectangular, and the edge have to be connected using constant, because I just extract the surface to make the copying 2, and then if there is no any associated extraction functionality to the other 2, and then you have to connect each edge point using constant. And assign the dimensions for copying hunch using the chamfer. And modify chamber distance for copying 2. And verify expected movement using the variables. We are adding column cap to existing model. Add variable names for column cap width, length, and height. Change the line color to identify. Place a rectangular. Assign the equal distance. And dimension using variables. And modify the variable so that cap dimension can be adjusted automatically. You can see the copying width. This direction is copying width, and then copying cap width will calculate copying total width, subtract, and copying hunch length times 2, and then this width automatically calculated based on this formula. and add the variables of column width and length to create a tapered caps. And make the variable for tapered scale. And you have to be careful so that the constraint will not change when moving the cap profile to bottom of copying. As you know, the solid is a 3D component and cap profile is 2D component. And I want to connect the copying and cap profile. That's why I'm using 3D dimension. And verify it. I just create some reference line to extrude a solid model. Generate the cap using the extrude from center of this profile. You can see why I added variable for tapered scale. And delete guideline. And verify the movement. Place a rectangular per column. And assign equal distance and variable, same as before method. And create the other rectangular. And assign constraint and variable per column group. Group length. Group thickness. Add variables to specify groove location from working point. Copy it and paste. Then rotating it to create a poke groove. Align and moving it into the column profile. Assign dimension to groove to line up with the column edges. Again, assign dimension to middle of groove so that align with the center of column. And check the movement. And add variables per column and groove height. The bottom of groove will matching with bottom of column. Change the variable order. And move this profile to temporary location. Using the three dimension to connect between top of the column cap and the column profile. Repeat it to specify the vertical offset of grooves from top of the column. And verify column profile movement. Generate solids per column and groove using extrusion. And confirm the column's movement. And deduct the groove volume from the column. Add a variable to specify the edge radius for the cap and column. Then assign it to the cap and column. And verify the movement using the existed variables. And I'm going to explain how to create the putting and create a rectangular for putting profile. And assign the constraint using the parallel. Add variables for putting width and length. Then assign it to the profile. Add a variable to specify eccentric of putting. And modify the variable to automatically can adjust for half of the putting width and length. Assign the dimension be based on working point. Verify the movement by putting variables. Move putting profile to temporary location. But you should keep in mind the constraint has not to change during moving the profile. And connect the top of the column and putting profile using 3D dimensions. And confirm the putting movement due to column height. And create a circle. Add a variable for the file. And assign pile diameter to the circle. But I will create guideline for the file so that define the file of location from putting edge, because you cannot specify the distance directly from putting edge to the center of the file. Specify constraint so that circle and line can join. and define file location using the variables. And move the file profile to temporary location. And create a solid for putting and connect bottom of putting and top of pile using 3D dimensions. But we need a considered variable for pile embedded depths. So I'm adding the variable pile embedded depths. And generate solid for the file and verify the movement. And finally, I will make the some pile array and verify this model. Added the variable for number of file and spacing. and change the type. And specify the formula to calculate the Pier location that be based on putting geometry. This direction is Pier length, putting length, and then you subtract Pier edge distance. So that's why I just time 2 here. And divide number of file. This is the number of file to calculate the space. So that's why I just subtract number 1. And repeat for Pier column spacing. Define Pier array using number of file and spacing. And verify this model using all of variable that will matching with your expecting movement. You need to spend your working time to verify the constraint and variable, but it will allow you can reduce the design man-hour for the potential project. All component movement starting from base point and guideline. This is a very important point. Also, you can assign positive and negative value for putting eccentric lengths. And I will change the guideline class to the construction. It allows you can turn on or off it for the view using the construction. And hide the guideline using the construction before creating it to cell. Move to cell and specify file path to save creating cell. And define cell origin and change the view to top view. Select the component. Then you can create parametric cell. And close this model and open the created model as a cell to assign the set a tag. And you can understand the file path where you should save the parametric cell. Because OpenBridge modeler goes to this folder automatically, and then you can select the custom pier or apartment to place in bridge model. Assign tag to each component. and verified it. This tag will engage to generate a quantity report in OpenBridge modeler. Finally, custom variable will mapping to OVM variable using variable mapping. Then copying length and slope will adjust by this function.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.